Okay, so we were talking about real images and virtual images. So a real image is when a light ray from a common point passes through, light rays from a common point pass through or are reflected by an optical device. Okay, as a result of that, the optical device causes them to converge, to come together and intersect at a point. Whereas in virtual images, it's almost exactly the same. It's light rays from a common point pass through or are reflected by an optical device that causes them to, you can pause me and write all that down, causes them to diverge in such a way that they seem to come from a different point, that they seem to come from a different point, not really from the object itself. Okay, so they diverge in such a way they seem to come from a different point. Like, look up here. This reflected ray is going out like this. This reflected ray is going down like this. They are definitely diverging. They seem to have originated back here instead of from where the object is. So that's what I mean by a different point. Okay, so these ones intersect at a point. These ones actually only appear to intersect. So number 2, actually, reflected rays actually intersect. Reflected, or I guess refracted rays actually intersect. Over here, whoops, what's number 1? Over here, the same thing, except they do not really intersect. What I mean by that is you have to follow back the reflected rays to find out where they appear to intersect. Okay? Characteristic number 3 is that these guys can be projected on a screen. So a real image, you can put a screen, a sheet of paper, can be projected on a screen. You can put a screen or a piece of paper where the image is formed and it will show up on a screen. So it can be projected on a screen placed where the image is formed. And virtual images cannot be projected on a screen. Okay, think about the image you see of yourself in the mirror in the bathroom. There is nowhere you could put a piece of paper or a screen that's going to form that image. That image is behind the mirror, but it's not really there. It can never get projected on a screen. Number 4, a real image is inverted. Inverted simply means upside down. Down. Whereas a virtual image is right side up or erect. Okay, so again, when you look at yourself in the bathroom mirror, usually your head is facing where your head is. You get a little freaked out if you looked in and saw your feet there. Okay, so the bathroom mirror is giving you a virtual image. And the 5th one here, examples would be like an overhead projector. A photocopier, a camera, your eye, all of these things create real images. Virtual images would be what we call a plane mirror, like your bathroom mirror. A magnifying glass is a virtual image. Okay, and more. So stay tuned. Okay, so real images, virtual images. The easiest way to tell, upside down or right side up. And if you put a screen there, could you form it on the screen? Those are the two, and these are true whether we're talking about mirrors or lenses. Okay, these are true for these characteristics are true for all virtual and all real images. Okay, all right. So now we're going to move to images formed by reflection, and then later we'll do images formed by refraction. So images formed by reflection. Okay, and there's a couple of subcategories. The first subcategory are images formed by plane mirrors. Again, that means flat, not curved mirrors. Okay, and just as a little reminder about reflection, again, like I said earlier, a ray of light coming in is called the incident ray. It hits a surface and it reflects off in such a way that the angle that this is the reflected ray, that the angle that the incident ray makes with a line that you draw perpendicular to the surface, called the normal, this angle of incidence will always be equal to this angle of reflection. It's called the law of reflection. And that's true no matter what type of mirror we're dealing with. It's theta I equals theta R. Okay, so that's just a little sub. So images formed by a plane mirror. Think about looking at yourself in the bathroom mirror. What are the characteristics of the image that you see? Okay, so the law of reflection is going to hold here. So light from your head might strike the mirror. It's going to reflect straight back. We could draw it back. We could find your head. Another light ray might strike your head, come in, hit the mirror, reflect off this way. We follow it back. Where they cross, that's where the head of your image is going to be. Okay? When a light ray strikes the surface perpendicular, it comes straight back. Because it's striking along the normal, the angle would be 0. So the reflected ray would be 0. No matter, again, whether it's a flat mirror or a curved mirror or a lens, you always need 2 rays to locate an image, because the image is always going to be where the rays cross. And so if you only have 1 ray, it's not going to cross. All right, so what are the characteristics of an image in a plane mirror? Image in plane mirror. What are its characteristics? When you look at yourself in the bathroom mirror, what do you see? Well, hopefully you see same size. Hopefully you see right side up. In other words, vertically erect. And I'm putting vertically in here on purpose, right side up. Okay? If it's right side up, if we go back and look at our characteristics of real and virtual images, it means it must be virtual. Where is it? Not, you can't tell from this diagram, but it's always same distance behind the mirror as the object is in front. So same distance from mirror as object. And the last characteristic, which I'm trusting that you noticed, is that if you wave with your right hand in a mirror, the image waves back with their left. So we say it's reversed right to left. Okay, that's why I did the vertically erect, meaning this way it's right side up, but your right hand becomes your left hand. That's why it makes it so hard if you're trying to, like, I don't know, put something like a corsage on or braid your hair in the mirror. It's like you can't keep which hand is doing what when you're looking, because it looks like your left hand and it's really your right. Okay, so these are the characteristics of a plane mirror. And tonight's homework is going to talk about the characteristics of a plane mirror, and it's going to talk about real and virtual. Okay, and then we'll get into equations next day I see you. All right.